Hello everyone, welcome to this video where we are going to discuss Form 4 Chapter 8 Vectors, Clone Past Year SPM questions. So I'm going to pick two past year questions to discuss, and both of these are from the paper 2. Okay, so as you can see here, we have an 8-mark question. So 8 marks question will be in usually in section A. Okay, so we look at this question here. You may pause the video and try to do it, and then you can compare your answers with my answers here, with my solution. So the first one here, this diagram shows a trapezium. Okay, so the word trapezium here indicates that PQ, the line PQ and the line OR are parallel lines. That's the first thing you need to notice here. So point T lies on PR. Point T lies on the line PR. Okay, we look at other informations. It is given that OR, the vector OR, means from O to R, meaning that's here along this line here. It is 15 vector B. Okay, so I can draw a line here. I can draw an arrow and write this 15 vector B. OP, the vector OP here is 4 vector A. And the vector OR equals to 3 vector PQ. So OR here equals to 3 vector PQ. So this is another additional information which we will come back again later. So first, express in terms of vector A and vector B, vector PR and vector OQ. So this is the easiest one. Everyone should score these 3 marks. Okay, so we look at A1. How do we answer A1? Vector PR. So PR starting from P going to R. So the shortest path is from here to here, but so far we don't have any information yet. So instead of taking this path here, we take from P to O and from O to R using the triangle law. Right? Of course, we can also take PQ to QR, but again, we don't have enough information for now, so we might just as well take the easiest way lah. PO OR. So PO, vector PO plus vector OR. However, if we want to use, since we want to express the vector in terms of vector A and B, if we want to use this, we need to look at the direction. The direction of 4 vector A is from O to P. You look at the arrow here. So since we are going from P to O in the opposite direction, so here we should write this as negative OP. If we want to use the vector OP. Okay, so I write this again here. And now the vector OP, the vector OP here is 4A. This one, 4 vector A. So I can substitute or replace vector OP with vector 4 vector A. And then for OR, of course, we already know that vector OR is this. So we can just write this as 15 vector B. Now for the second part, we have the vector OQ. And for this question, actually, usually the second question is harder, but here this is relatively easier compared to other past year questions. So OQ here, from O to Q, if we are going to take this path, again, we don't have information, so we can take from O to P, PQ, or we can also take OR, RQ. But now we don't have information for RQ, so we might as well just take OP, PQ. So OQ equals to OP, vector OP plus vector PQ. So we already know vector OP equals to 4 vector A, no problem here. So now comes the problem, vector PQ. Since we haven't have the information for this, we need to get the information. I think it's quite obvious that we have to use this. Okay, vector OR equals to 3 vector PQ. Since we need PQ, we only need this. We want this. Okay, if we move the 3 here to the other side, it becomes 1 over 3 vector OR. So it means that PQ equals to 1 over 3 vector OR. Let's see if we substitute vector PQ with vector 1 over 3 vector OR. Can we proceed from here? Okay, so we Of course we can, because OR is already given. Yeah, OR is already given here, which is 15 vector B. Okay, so the next step, we just substitute vector OR with 15 vector B. We have 3 marks here. So since I need space for the second question here, I'm going to clear the board here. Okay, so now since I already cleared the board and I write the 2 answers here on top here, because for vectors questions, we always have to refer back to the previous answer. That's why I have to write it here. Later we can refer. Okay, so now we go to question B. So we look at question B. You may pause again the videos to read the questions. It is given that vector PT equals to K vector PR, where K is a constant. Yeah. So find the values of, so first we look at where is vector PT. PT is here, and the vector PR. PR is here. Next, find the value of K if the point O, T, Q are collinear. Right? So if O, T, Q are collinear, in other words, it means they are along one straight line. They form a straight line. The 3 points, the point O, point T, and point Q, are on one straight line. So usually if this is given, what information can we get from here? So if O, T, and Q are collinear, if we have a straight line where we have a O, T, and Q are collinear, there's a lot of information we can get from here. Yeah. For example, we know that OT is parallel to TQ. So if we want to write this in a vector form, vector OT equals to maybe is a lambda TQ, where lambda is a constant, it's a value. Yeah, because vector OT is parallel to vector TQ. Besides this, we can also write that OT is parallel, to OQ, because OT and OQ are on the same line, same straight line. Yeah, so these are the more general information that we can get that you need to keep in mind when solving this type of question. Okay, so I clear this for now. And so we try to solve this question. Okay, PT given vector PT equals to K vector PR. Whenever you are given this type of question, what you need to do next, even though you have no idea how to find the K for now, we usually have to convert these vectors into try to express these vectors in terms of A and B. So you can use what you get from question A as a hint. Yeah. So since A, they want you to express the vectors in terms of A and B. So the next question here, we can try to express or convert this to vector A and vector B and see what we can do from there. How can we convert? How can we express vector PT in terms of A and B? So PT is here. PT is here. So we can use PO and OT. PO and OT, the triangle law here, to express vector PT. So PT we can write as PO plus OT. Okay, PT can also be written as PO plus OT. Next, PR. Okay, PR can also be expressed as PO plus OR. Okay, PO plus OR. So here we can write this as PO plus OR. So we are trying to break these vectors into simpler parts so that we can express all of this with vectors A and vectors B. Okay, now so the next thing here, PO. PO actually is already given here, right? This is vector OP. So PO is actually the in the opposite direction to vector OP. So if we want to write PO, PO is actually equals to negative OP. This one I think I already discussed in the question A just now. So we can directly substitute vector PO with negative 4A. And then now comes the problem, OT, right? OT. So we don't have the information for OT. However, we do have the information of OQ, right? OQ. We get OQ from question A2. So what if we try to express OT in terms of OQ since they are given collinear? So that is where this information comes in. Since they are collinear, we can say that vector OT equals to maybe we want to use we use instead of using lambda, we can use like another constant like h. So h o q. Okay, vector OT equals to h o q. So why you want to change OT to h o q? Because after we express vector OT with h o q, we can express OQ in terms of A and B now. But then maybe you say, hey, how about the H here? Suddenly we introduce another unknown. Okay, we will settle that in a moment. Okay, later you can see. Here we have PO. We already know that PO is -4 vector A. And OR, of course, we have the vector OR already. We know it is 15 vector B. And now OQ here, the vector OQ, we just substitute with this and we will get this. Okay, H. So the vector OQ we substitute with 4 vector A plus 5 vector B. And the K here, I think we just expand this. Okay, so you get -4 K vector A plus, okay, the K we multiply to the 15, you get 15K vector B. And if I continue from here, because I have not enough space here, I just move to the other side here. I start from here, so I get -4 vector A plus 4H vector A. Okay, we expand this. Okay, so the H have to be multiplied to 4 and the 5. Now, since we have vector N, vector A here, we factorize this. You get -4 plus 4H vector A plus 5H vector B, -4K vector A plus 15K vector B. So after we reach this state, which is always what we try to do, we can compare the coefficient of vector A. Okay, I use a red color here. We can compare the coefficient of vector A, and we can also compare the coefficient of vector B. You should do a lot of question exercise like this so that you know when you reach this stage here, the next thing you do is comparison. Compare. By comparison, -4 plus 4H, this one, equals to this, equals to -4K. 5H equals to 15K because they are coefficients of the same vector. That's why we can compare this. Okay, so 5H equals to 15K. So now we only have to solve this. Since we are looking for the K, we just solve it. So I think we start from here. This part here is easier. We want to find K, so we bring the 5 here. Okay, so we have H equals to 15. Then if we let this equation 1, this equation 2, we substitute H equals to 3K into equation number 1. Yeah, substitute this into here. So you get -4 plus 4 which is 1/4. Hence, the answer is 1/4. Now we move on to question number 2. Here is another past year clone question. And this time we look at the marks allocated. Here is the total is 10 marks. 10 marks means this is from section B. Paper 2 section B, 10 marks each. Let's look at the diagram. Diagram shows a triangle PQR. Okay, so we have a triangle PQ and R. The straight line PT, okay, we have another straight line here, PT, intersects with the straight line QR. Okay, so here at point S. Point V lies on the straight line PT. So we look at additional information here. Given that QS the vector QS is 1 over 4 of vector QR. Yeah, QR here. PR, vector PR equals to 8x, vector x. Okay, so PR here from P to R, okay, is 8 vector x. PQ, from P to Q, this is given as 10 vector y. Okay, so we look at question A. It says express in terms of x and y, vector x and vector y. Vector QR is here, vector QR, but so far we don't have any information here yet. So we use another path from P to Q, from Q to P and P to R. Yeah, so QR can be expressed as QP plus PR. Okay, QP, PR. QP is in the opposite direction to 10y or PQ. So we can write QP as negative PQ plus PR. So PQ is already given here is 10y. So negative 10 vector y. PR is given 8x. Hence this is a 1 mark. Question number 2, A2. PS, from P to S, again we don't have information from here yet, so we can either take this PQQS or PRRS. Both you'll get the same answer. Okay, for my solution here, I will take PQQS. So I write vector PS as vector PQ plus vector QS. PQ, no problem. We know that PQ is 10 vector Y. Problem now is the vector QS. Yeah, the vector QS. So we look at the additional information here. We found that QS, vector QS actually equals to this. Okay, so we can write vector QS as 1 over 4 vector QR. And vector QR, even though there's no information here, but we can get from A1. Yeah, vector QR is here, which is this. So we just write this as 10 vector y plus 1 over 4. Use a bracket always for negative 10 vector y plus 8 vector x. This one here, substitute into this. Okay, now we go to question B. It is given that vector PV equals to K vector PS. Okay, PV, PS, and vector QV equals to H, a constant, times the given vectors here. Okay, so find the values of K and of H. We need to find these two values. So usually, yeah, for paper 2 questions like this, yeah, again, if you look at question number 1 that I showed you just now, we are trying to combine, and also we try to express all the vectors in terms of x and y, and then we compare coefficients of vector x and vector y. That is what we usually do, so we can try to do that first. Here we have a K, we have a H. We try to do something so that we can combine both of this information that we have. Let's start from here. Okay, maybe you still don't understand what I mean just now, but you'll see. Okay, so we start from here. And then we try to see whether we can express the vector QV in terms of by using this information here. Okay, so we try. So QV is here, right? QV is here. So instead of taking this, we can take QP and PV, right? Why am I using this instead of using the other way around? Because you see here, we have a PV here. So if we can express QV with QP, vector QP plus vector PV, we are now relating this equation to this. We are now relating both of these. So you see, QV equals to QP plus PV. So it's written here. Okay, I write the other side here. And then, given that vector PV equals to KPS, right? So I can substitute this vector PV with KPS, K vector PS. QP, we already know that QP is this one, the opposite direction of this, right? QP is here in the opposite direction to 10y, so we have negative 10 vector y. So we rewrite this, and you can see that this one I expand this, expand, and here, if I am able to convert vector PS and express this in terms of x and y, I will be able to compare the coefficient of vector x and the vector x and vector y to this, and then I can solve. I can find k, I can find h, both, like what I did in question number 1b just now. Let us see how are we going to write PS in terms of x and y. You see here we already have the information PS from a previous question. PS here is this, hence we just have to write PS in terms of vector y. Next thing, we just simplify both sides. Yeah, we simplify it. Okay, so here I try to expand it. Now we already show both sides of the equation in terms of vector x and y, and we can do the comparison. Yeah, so look at this one, the coefficient of x, so 2k equals to h. Then the coefficient of this equals to this, sorry, here, this one, don't forget the negative sign as well. Here we have k equals to h over 2. If you want, you can use the equation number 1, equation number 2 thing again. Okay, so I label this equation 1, equation 2, substitute equation 1 into equation number 2. You get 15 over 2. H is 8 over 11. And then you substitute your H equals to 8 over 11 here in order to find your K, right? So you will get the K is 4 over 11. And this is for question B. We are not done. We still have one more question, the C here. I'm going to do the C here because this is quite short actually. Given vector PT equals to A vector x plus 10 vector y, where a is a constant, find the value of a. Okay, so now we want to find vector pt, but actually there are very less information that we can get from here. So what we can do here is, since ps is a part of pt, right? ps is a part of pt, we can try to write pt in terms of ps. We can write pt equals to lambda ps. So maybe you ask, hey, why we suddenly have to write this? Because we have the information for ps here. We don't have any other information from this side here for pt. So we have to convert pt, express pt in other ways that we have the information. So if you see, if we write this pt equals to lambda vector ps, which is equals to this. PS from question number 1, from A2 here, we already know is this. So I can write this PS as 15 over 2y plus 2x equals to AX plus 10y. So again, we have another similar situation. If we are able to simplify all this, we can compare the coefficient of vector x. Oh, we try. Now we try. And then from here, we can, I use a different color so that you can see, we can compare the coefficient of vector x again, like what we did just now here. Yeah, we compare the coefficient. So this equals to this equals to this, because both of these are the coefficient for vector y. Okay, so I write here at the side here, 2 lambda equals to a. Yeah, this one 2 lambda equals to a. 15 over 2 lambda equals to 10. 15 over 2 lambda equals to 10. So from this equation, we can find the value of lambda, which is 3 over, let me see, 4 over 3, sorry, 4 over 3. Over 3, that's the answer. So I think my video stops here, and I'll see you in the next video. Thank you, everyone.